things that I noticed when people turned in some homework last week. And last week was really, answer these questions and then copy and paste into a Word document. And what I saw was a lot of people would type things in this interactive mode, and then they just did a screen capture or just did a copy and paste off of here. We really need to have you write these code and put it into a .py file. And that's, so if you have that note, that means you did this. Or I had somebody say, I don't remember how they phrased it, and they're like, well, it doesn't look the same. You have to go up here and we have to start an interactive file. The easiest way to do it is this file new, and that starts a brand new blank shell. Now, at the beginning, I also showed you how you can do a template, and that's probably not a bad way, and that way you can store some of these things that we're going to talk about in here in your beginning of your file. So things like your name, the assignment, and those comment tags are really handy. The other thing that we almost always put in is some form of an input, and that input just holds the program open if we run it directly from our folder. If we run it in idle, it'll pause anyway. But if we run it directly, and there's a couple of things I want to show you how that running directly work differently than in the idle environment. And so this week we're going to introduce you to an escape character that'll sound a bell signal. Well, that doesn't sound very exciting, but it's the beginning of how can I interact and make noises and various things with my computer. Those don't necessarily run in that idle environment very well because you're inside of a shell and it doesn't pass it out to the computer necessarily correctly. So there are some times when we want to run a program directly. And so if we don't have this input, your program will just execute and stop, and you will just see like a flash of a black box and it'll disappear in most cases. So chapter 1 really started talking about the basic format. It introduced you to our comment codes. Well, we're going to do some things with text and with numbers. And because we're a little limited on time, I'm going to actually jump ahead a little bit. There's a lot of things in this book, so you still need to read through the book. There's no shortcut for reading through and kind of trying some of these things. But we want to show you some of these items here. So a lot of our things happen inside of a print statement. One thing that I am really bad about doing is I always want to capitalize. Capitalized print is not a key word in our programming environment. But we have these escape characters. So if I do a /n, and I put it inside my quote mark, that /n means what? New line. So we're going to add a new line, and it's going to bring it down one line. Well, that's not the only escape character we can have. So the other one that we use a lot is the tab character. Tab character will allow us to kind of format our text a little bit. And that's where the beginning of this book, or this chapter starts, is it introduces us to some ways we can put text on multiple lines and some other ways we can manipulate, and introduces us to something called ASCII art. So ASCII art, it really comes from the fact that we originally had all of our characters in something called an ASCII table. And way back in the 50s and 60s, people came up with ways to make what looks like some kind of a graphic art out of text symbols. And so you see that in the book. We're not going to spend a lot of time on it yet. We'll show you how to create some of those. But these escape sequences, /t/n, so we can put a lot of things in here and manipulate our text around. So we can do more than one. So this one will now jump down 1, 2, 3, 4 lines. That's very handy when we want to format how our text looks. But what I think is more important, and you'll see on page 24, any of these boxes and tables, that kind of gives you the highlight of this chapter. So notice there's backslashes, so there's an A that sounds the bell. So if I did an A, that should ring a bell. And if I run this, and I save it, documents, CMIS 210 Spring, and I called this week 8. So if I run that, all it did was put that little box on the screen, and I know that's very hard to see. That box says, hey, I tried to run that file. We'll see if it'll actually make any noise on this particular one here. So now I'm going to do the same program. 210. So now I'm going to run that same program week 8, but I'm going to run it in the command line. So I just double clicked on it and it shot to the other screen. So notice it's staying open because I just put that empty input in there. And when I click the enter, it disappears. So in this particular case, on this computer, it doesn't like it and doesn't make any noise. So it may depend on what kind of computer you have, whether it's going to actually make a ding or not. But it's the beginning of how we start to interact with that. And so that system bell is generally a speaker inside of the computer itself. So if you have a desktop computer, you may hear it make a little chime noise or something. But it's worth investigating, but it's interesting how the behavior differs. So I don't see this little character because it interacted differently with my computer when I do that. So that's why we write that input statement like we do. Yes, it's still running. So that input there is what held it open. And I didn't put any text or verbiage in to make it very clear and apparent. So our book always has you doing with a new line or two, I think it is, and then a press any key to exit. So you can get a little fancier and have it like this, and then if I saved it, then it's going to look like this. If I run it directly, so notice it just makes it a little cleaner and plainer about what's happening there. So same way here, now we exit, and then it cancels the running of the program. So make sure you've looked at table 2-1 and those escape sequences. That's how we can both print some of those commands and we can also use them. So the most common thing we really use, quite frankly, is the new line. That way we can break apart our text in there. Page 24 starts talking about something called concatenating. And concatenating means really we're just putting things together. And the program that they demonstrate, a program here called Silly Strings, is interesting. And I'm going to actually open that one up really quickly. So I'm going to cheat a little bit and open up an existing one because this will save us a little bit of time. You should probably go through and do this. What this tries to do, so notice here it says we're going to show you what using the plus symbol looks like. So really we're taking text and we're able to manipulate it around. And that doesn't seem particularly impressive right now. But when we start building some games, and so fairly quickly we're going to build a hangman game and some other things, that ability to put text together directly is a really handy skill. So I'm going to go through some of this really quickly. So here we have a new line character, and then this string plus may not seem, and notice here we even split a word. Over here we inserted a space because it does not do it by default when I use the plus symbol. So this line here puts those plus symbols, puts all of those together. This single backspace escape character just allows me to put it on multiple lines. The computer could care less. That line could be 500 lines long, but for us, it's kind of nice to be able to break them apart. And that single line just says, hey, you're moving it down to another line for readability for the humans. The computer could care less. So what this really does is it puts all of that together in one line. And what I'm going to do, notice I said we can use that comment code also for troubleshooting. Well, I just put that in front of all these lines, so they're not going to print when I hit run. So when I click run, it's going to say, hey, do I want to save it? I'm going to go, sure, why not? And it put that string together. This string may not seem terribly impressive, but what you don't know is that it's really one long string created from the concatenation of 22 different strings broken across 6 lines. All right. So if I look at that, it put that all back together and put it into these open clearly. So that one. So it put that text all together into one line. That's a really handy skill for us to learn and how to deal with that. There's a couple of other things we can do. So here I'm going to take this comment code out now. And before I can run it, I'm going to have to save it. But there's something else that's interesting, and Python is really nice in this regard. So this last line, it says pi times 10. And Python is smart enough to know that when I write it this way, it's actually going to print pi 10 times. We all like pi at early morning, I hope, maybe. So I'm going to click run. And I got to drag this up so you can see it. And so here it says, oh, pi, 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 pi. It sounds like a toddler going on about pi. Well, we can do that, and it was really easy to do because all we had to do was take our pi and say we're going to do it times 10. If I would have did it times 100, we could do it 100 times. And in fact, I could even put in a new line character in there. Oh, I want to grab the wrong one. And now it would put an extra space after each one, and so we could run this. And if I didn't do anything really wrong, it's going to say pi times 100. But notice our editor even says, it tries to show me that it compressed them. And so there is pi written out 100 times with a space in it. Kind of a quick and handy way to do something. And if you think about a toddler saying over and over again, I want my cup or something, that's the way we can do it. So concatenating just really means that we're putting things together. We're putting them together. And so on pages 26 and 27, it tells you how this program works. So the repeating strings on the bottom of 26. So we can all do that one pretty easily. It just takes a little practice to try writing those strings down. The plus symbol means we're just going to put them and string them directly together. If we do that, we have to be careful because we have to put the spaces in when we do that. But we can also do it when we're working with some text, and we'll show you what we're going to look at a little closer here. So the next problem we want to look at is we want to introduce you to numbers. Well, we're all used to numbers, right? And here's where Python is really nice to us. Almost every other language, at least lower level languages, we have to specify exactly what kind of number it is. Python really has two different types of numbers we can use. So we have what are called integers. So in other words, you've called them whole numbers. So 1, 2, 3, 4, 5, 6, 7, 8, that's a whole number. That's an integer. Integers generally take up less space in our computer. We can write them really small, and that's one of the advantages of them. But they have a limited range. So in most programming languages, they can only go up to a certain value, and they can only go below to a certain value. So a lot of languages limit it to about 32,000 positive and 32,000 negative because of the address space. Python gives us some more values than that, so if we really want to use it. The other one we're going to use is something called a float. And a float just means it's got a floating decimal point. That decimal point can happen wherever we need it to. And Python handles those kinds of numbers very, very well. So, in fact, for the most part, we can use them interchangeably, but the integer gives us some advantages in a lot of our calculations, and we'll show you what we're talking about there. So we've had strings, we've had integers, and we've had decimals, or what we call a float. And so we need to practice working on those a little bit. There is, on page 27, we start writing a program that allows you to add, subtract, and it's going to keep track of a hippo's weight. Yeah. All right. And so if you look on page 28, there is a program here. So we're going to take pieces of this and we're going to write them out. I'm going to probably shortcut this a little bit because we have a little bit of a time limit. So I'm going to bring this across and let you see what it looks like. This program is really available. You can go search it out. In fact, if you look under course documents, I actually have a place you can grab it. But it's useful for you to write this so you understand what's going on. And so we know print statements. So print statements aren't that hard. We just enclose them. We call the print function. And then we say, if a 2,000-pound pregnant hippo gives birth to a 100-pound calf, but then eats 50 pounds of food, how much does she weigh? Press the Enter key to find out. All right, so I'm interested on this very first part. So it says print 2,000 minus 100 plus 50 equals. All right, so because that's in a quote string, we can't do anything with it. But notice what happens here. Those aren't in quote strings, and it's going to perform that mathematical operation right now for us. So if I run this, and I just want to look at the top piece. So it's waiting for me. So notice it says press the Enter key to find out. So it's waiting right there to run the next line. So I'm going to press Enter. 2,000 plus 1 minus 100 plus 50 equals 1950. But notice how it got that answer. We printed 2,000 minus 100 plus 50. We didn't just print out a value. We made it calculate it for us. And we can separate things in this print statement with a comma. And we did. We said equals. And then it printed out 1950. We could put any mathematical operation in there. So Python's a good way to check some of those things. When we look at Facebook, and somebody will have one of these puzzles about, if I have 37 plus 14 minus 12 divided by 47, you could actually plug those right into this and look at it. Well, we have a little more. We can do some other operations. So here we added, here we're multiplying. 6 times 3 equals, well, hopefully our computer says that's 18, so let's find out. Yep, it can multiply. If our restaurant check comes to $19 with tip, and your friends are splitting it evenly, how much do you each owe? Well, we can run that. I lost it there behind in my quest for glory. Hang on a second, let me drag this one out of the way. So 19 divided by 4 is $4.75. So we can divide. And 107 gold coins, and they divide the booty evenly. How many whole coins does each get? So now we have a little different mathematical operation. So we're dividing 107 by 4, but we don't want a fraction. We want a whole number, the closest whole number to that. So notice I've got 2 lines there instead of 1 for divide. And notice there's a table 2-2 on page 29, and that says, all right, that is an integer division. So it's going to return the closest integer it's going to find. So we're going to run this and see if it did. So scroll up here a bit. I meant to rerun it because I probably did something stupid. All right. Now I'm going to run that. I dragged it around all over. All right. We've got our division. They find a chest full of gold coins. We divide it out, and 26. So it just dropped off that last piece, right? Rounded it off. But that maybe is what we want. I can't divide those gold coins. But I also have another operation, something called the modulus operator. And that modulus, I can find out how many are going to be left over. And 107 modulus 4 tells me there's 3 gold coins left over. And that's oftentimes what we really want, is we want to know that remainder. So if you go back to grade school, my kids are in 3rd and 4th grade, they're dividing and having to show a remainder. And that's what that really is. That modulus operator is a remainder of what's going on. So here we have that operation, so we're saying 107 remainder 4. And on page 29, all of these operators that we're going to commonly use are listed. So plus, minus, times, divide, the division integer, and the modulus. And those kind of go hand in hand. So we don't use the times key or an X, it's actually that star key. And the other thing to keep in mind is that these numbers and the values follow that same mathematical order of operations that you learned in school. So we're going to multiply before we subtract. So if I need to change that, I use our friend the parenthesis to change some of those. So math operations are where our computer really shines. We can do these things over and over and over again. What I want to do now is add one more component. And it's nothing scary, because you guys all did this in second grade. You started seeing that there's something called variables. So I'm going to introduce you to a brand new program, and I'm going to write it really quickly. So I'm going to say, I want to create a program, and I'm going to say name is equal to Mike. So all I have done right there is I have created a variable, and it's called, the variable name is name. Mike is what is being assigned to it. So it's Mike is being shoved over there. Well, I can double check and make sure that that's really what I have in there. And I can run it. So let me put in a blank input. So now I have a really short program. I don't have any comments. It's pretty ugly, but I can save it and run this and see what it's going to do. We'll call it Mike. And down at the very bottom, it actually says, oh, yep, you displayed Mike. I don't know where my cutoff line on my recording is here. Oh, dang it. Let me make that a little. The recording doesn't go all the way to the bottom of that monitor to make it fun here. All right, so it printed out Mike. So it took that variable and it said, all right, I'm going to output that variable. And most of the time, we really want to use variables for everything. We don't want to hard code numbers, because when we hard code a number, we don't know what it means in the program itself. So I've got one here, and I could change it. So I could add a little more. So I could say, hi, my name is. And when I do that, now we hope it's going to run. Save it. And it says, hi, my name is Mike. So now I'm combining some of those skills. I'm putting in some comments there. So 31 talks about creating a variable. Notice, did I have to have a separate section where I said, I'm going to call this a string like we did in our pseudocode? Python is almost too easy in this regard. It says, oh, well, you created a variable, you're putting a string into it, it must be a string variable. All right. There are times this comes back to bite us in the butt a little bit. But for the most part, we don't have to declare our variables until we actually assign it a value. So here, this is the assignment, and we're putting in a variable in there all at the same time. So 32 talks a lot about naming variables. And here is where I'm going to be hard on you guys about this. There are really two different ways that we can name variables. Just like in our pseudocode, you could name variables a couple of different ways. And so way one is using the underscore. We can't put a space in there because the computer reads it, hits that space, and says, I'm done reading. You can use the underscore, or you can use kind of the camel casing. Either one will work, but I want you to be consistent in your coding. I prefer the camel casing. It is up to you, though, which one you prefer. Underscores, camel casing, same thing. But what you want to think about is creating a list of your variables when you need them and making them consistent, and you also want to make them self-documenting to a point. So there is kind of this gray area. I can write a variable name that has meaning. I can also write one that is so long, because Python will let you make a variable name 256 characters long. That's great. It's kind of unwieldy. But I also want to make sure I'm not just putting in, because I could use the same variable, could be done with an X, but X doesn't tell me anything. So I want the idea of self-documenting, something to describe what it is, but I don't want to get too... So that's a legal variable. It's got a lot of information in it, but it gets unwieldy. So a couple of words at most generally are a really good way to do it. Sometimes I'll kind of break them apart, like all the names of the characters if I'm doing something with people. I use like name underscore at the beginning. So I want to be consistent and I want it self-documenting. So when I look at it, I know what it is, but I also don't want to be so scary with this long name that I mistype it and my program crashes because I can't keep the variable name straight. So it is kind of a double-edged sword. You want both of those. So page 31 talks about that and the idea of self-documentation. I'm going to delete all this except for my input right now. And I'm going to just use the same program. We also find it really, really handy. So I'm going to call this greeter, just so I know what's going on. And it would be handy if I could take a person and get information from them. And luckily we can do that. And I can do it all in one step. So I'm going to create a variable named name. And I'm going to assign it a value. But instead of just hard coding a value in there, I'm going to get the input from our user. And inside that input statement, I can actually write something that displays on the screen. Please enter your name. So this gets a little more complicated. We have name equals, so whatever we input is being shoved into the value of name. Well, we're going to double check that that's really what's going on, and we're going to print out, we can just print out the name. Notice, because it's a variable, I don't put it in quotes. If I put it in quotes, it's going to print out that. We could also do it, you could do some other things. You could put in some text. Welcome to Peru, space, name. So now, if I run this, file, save, it says, enter your name. Now, there's a reason why I'll show you, but I'm going to clear out my spot there. So it actually stored what I had before, which is kind of creepy. And there is a reason why I'll close that a lot. Because sometimes it doesn't always release things. So, move this over. So here, it said, please enter your name. I typed it in, and now it reset it. That's why we do that garbage check. Because it will pick up stuff that's stored, especially in that idle environment. It doesn't always clear those variables out if we use the same one. So welcome to Peru, Brad. Got it. Well, we can input data really, really, really easily. So page 34 talks about how we can do that, how we can put that in. We can also then start manipulating our text a little bit. So 35 starts talking about the quotation manipulation program. So if you did any JavaScript or you've seen some other languages, we're going to talk about what we call a dot notation here. And I'm going to show you what we're talking about. close that. So we're out of that one really quickly. So I'm going to open this one up. Since we're already at 10 o'clock, instead of writing it from scratch, and I'm going to walk our way through this one. So this takes an original quote. So the IBM chairman, 1943, said, "I think there's a world market for 5 computers." Well, clearly this was a vision that was wrong. So we're going to look at it and see if we can manipulate this quote in a couple of different ways. So here we just printed that. So here we said, here's my quote. I'm assigning it to that value. Here I'm going to print it. So that's going to print the original quote unchanged. I have a couple of really handy things I can do. So here I'm going to print the quote, and I'm going to use that dot upper, and notice it's a call to another function. So we actually have a parenthesis in there, another set. So we're going to print it uppercase. We're going to print it lowercase. We're going to print it as a title text. And then finally, we're actually going to do a little manipulation of that original quote. I'm going to use the replace function, and it's going to search through and find 5 and replace 5 with millions of. And then we proved that that quote itself didn't change. So we manipulated it, we changed it what's output, but we didn't actually change the original text. So, ta-da, the original quote. I think there's a world market for 5 computers. Here we made it uppercase. Here we made it all lowercase. Here we said here it is as a title. So title capitalizes every word in there. And here we changed that 5 computers to millions of computers, and then we have the original text back. Pretty handy. Where this comes in handy, think about we ask a question of somebody and we say, hey, would you respond to this survey yes or no? Well, a capital Y is different than a lowercase y. But I can use this to manipulate my text and make it all uppercase or make it all lowercase. I can take a string of what somebody types in and I can capitalize it or make it lowercase. So we can manipulate our text around a little bit. So I encourage you to try that. And then on page 38, there are a list of, and this is not inclusive, there are other string manipulations we can do, but I want to show you where we're at in some of these. So we have upper, lower, capitalized, title, strip, and the replace. The replace will particularly come in handy as we start moving through here. So we can take text and we can move that around all over the place. All right. So we're getting a little closer. Your assignment this week, we're going to write a program right now very similar to your assignment. So I'm going to start a brand new program, File New. And I'm going to make this, I'll try not to type down there where you can't see. So the first thing I'm going to do is I'm going to call this one Trust Fund. And we're going to roughly follow the book, but we're going to make a few changes because I don't want to add all this. I don't want to have a 3-line introduction. I'm just going to print out Trust Fund Program. I don't want to spend quite as much time on that. And so we're going to have a couple of things that are going to be, we're going to input in the costs so that we can figure out a budget for our trust fund. We all know somebody on a trust fund, don't you? Does anybody? You do? Wow. I want to meet, you do? I want to meet people on trust funds that live the high life. I want to be Paris Hilton. No, I don't want to be Paris Hilton, but let's do this anyway. So we know that their car expenses are going to be a little different. So we're going to say one is car, and I'm going to assign it a value because I'm going to allow you to input a value. Input, and I don't like Lamborghini because I can't spell it, so we're going to call it, what's another brand name that's very expensive? And if you say Dodge, then we know that our expectations are different. Maserati. Tune-ups. So they're going to get to input what the cost of a Maserati tune-up is, right? So, and then we also know that they're rent. Now, we know they're probably going to buy it, but we're going to have apartment. It would be helpful if I put the input in there. Notice I didn't put the rent in Lincoln, which I think is already high enough, right? So, all right. So other things they're going to have. Because certainly I have to worry about my jet rental, right? Private jet rental. So I'm just adding in a couple things. We're going to do one more. What other things? We're not going to do like 10 or 20 different things. We're going to do a couple here. What other things do rich people have to worry about that we don't? Oh, good idea. Yeah. Well, most of us pay taxes, but I think theirs is going to be a little different. Taxes equal input. Taxes on stock market. We'll do that. All right, so now, if I run this program, it's going to ask you to put in 4 different prices for things, right? And so I want to come up with a new variable, and I want to call it total. And I think Python is smart enough to put car plus rent plus jet plus taxes. Okay, and then we're going to print out total. And I'm going to hold an input at the bottom just so I know that the program will stay open. So here we have a shortcutted version of this program. Does anybody see anything wrong with it so far? Does our syntax look okay? Python's pretty smart. All right. I'm going to run it. So I'm going to have to save it to something, and I'm going to call it rich. And it's going to run. All right, hang on. I got to drag this over. All right. Now I need to make that a little shorter so I can drag it up. All right. So Maserati tune-ups. What do you think a tune-up on a Maserati is? 15,000? A tune-up, yeah. Yeah, why not? 1,500? All right, 2,300. Some of the cars, the very expensive cars, even just getting them worked on is unbelievable. A Manhattan apartment. Has anybody looked at rent in Manhattan? I'm going to say 10 grand, and that's not much of an apartment in Manhattan, unfortunately. Private jet rental, 25,000? Sure. We're just making up numbers. And then taxes on stocks. 10,000? We're going to put in numbers that we don't quite understand. So when I hit enter, it should then print out my total for the month, right? Let's see what happens. Whoa, wait a minute. What happened? So are those the numbers I put in, but it just concatenated them together? So when I do inputs, and so this is kind of that lesson, when I do inputs into Python, everything is returned as a string. So the computer takes in whatever I put in as a string. So I need to do what's called casting or conversion into another type of variable. So I'm going to stop my program here. And I'm going to come up here and I'm going to have to make a little bit of a change. So I know that car right now is a string variable. But I want to change that. So I'm going to write car equals, and I'm going to use another function. So I'm going to use the integer function, and I'm going to pass in the value of car. So I'm going to take car, is what I'm really saying here, and I'm going to convert it to an integer. So remember that computer reads from right to left because it's taking car, converting it to an integer, and shoving it to the left of that equal sign. So I could do that for all of these, but maybe there's an even shorter way I could do this. So I can usually put a function inside of a function. So I'm going to use the integer function, and I'm going to bracket around my input. So now I did that all in one step. I took in rent, I converted it to an integer, and sent it over to the rent value. Does that make sense? So this is a shortcut way to do that. If this doesn't make sense to me, I can certainly take it in this way. These do the exact same thing. These two lines does the same thing this line does. This just says I converted it to a string here. I got a value in, some kind of string. Here I explicitly converted it to an integer. Did the same thing here, but now I just put those inside of the same function. So I know that's a lot of stuff really quickly. I'm going to hit run, just see if it works, because there's no other way to do this other than running. I think we did 2,300, 10 grand, 25,000, and 10 grand. And now it says our monthly budget for just those items is 47,300. So the lesson here is everything we do when we get an input, it comes in as a string. And we actually want that. We really want that, because if somebody puts in something we don't think they're saying, hey, let's input a number, and they put in ABC, it's going to break unless we do this. And so let's see what happens if somebody does that. So I'm going to exit this. And let's see what happens if I run this and we do something really dumb. Maserati tune-up, ABC. Oh. And it's going to break right away because it's trying to convert ABC to an integer. And can it do it? No. No. So if I did not have this line in here where we said it's equal to an integer, it would be fine, but we wouldn't be able to manipulate it as numeric text. So in the future, we're going to develop some ways to check our data first. But for now, we're just going to assume people always put in what you tell them to put in. So I told them to put in numbers, and luckily everybody did. So on the bottom of page 43, it looks at a couple of different ways we can convert text around. So I can convert this to an integer. I could have also posted this, and I could have called it a float. Because we're rich, we don't care about the decimals. But those of us that do, maybe we needed to put those in terms of a floating number. In other words, it has a decimal. I could have converted that to a float. And I could even convert something into a string. Now that doesn't make any sense. It already says, hey, you're already a string, convert it to a string. But there are times we need to take a number and make it back into a string. Or we want to make sure that whatever we have in there is looked at by our program code as a string. So Page 43 talks about a lot of those kinds of conversions and what we can do. Page 44, as we go through some of this content. 44 says augmented assignment operators. Here is what I will tell you that I am really bad about never using these. They work in this language, but they don't necessarily work in other languages. So an example of that, if I'm calculating a number, and I want to say x is equal to x plus 1, or 2, whatever I type there. So I can shortcut that, and I could really just say x plus equals 2, and that would add it on. To me, though, so that really, I don't see a lot of shortcuts and savings in it. You're welcome to use shortcut assignment operators. I just don't do it a whole lot. So on page 44, if you don't look at that section, I'm okay with it, but you may find that there are codes that you're going to run into that when you see that, you know what it does. In my own coding, I don't typically use it. I will admit to that. I'm not quite that lazy in there. But again, it doesn't always use it in every one. So I want to do, and the last thing we're going to look at here really quickly and then start on kind of the homework piece, is we're going to rewrite that useless trivia game that in the beginning of the chapter you're going to have went through. So I'm going to eliminate some of this. I'm going to drop that. And I'm going to now call this useless trivia. And what this does is it takes input from a user and says, gets some information about them, and then it can input and output data. So the first thing I'm going to do is I'm going to use my name again. So my name equals input. What is your name? So now we have a variable named name. It's getting in a user's name. I'm going to do one called age, and I'm going to say input how old are you? Now, because age is a number and I want to work with it, I'm also going to then say age equals the integer of age. So in other words, whatever value they put in is no longer a string. I converted it to a number. And then we're going to get the one that nobody likes. We're going to use weight. And then we're going to do an input. And I'm going to show it this way. I'm going to convert it to an integer in one step. Input, what is your weight in pounds? Can't spell, P-O-U-N-D-S. So this time, so we showed two different ways to convert that. So this one converted it directly. This one converted it directly. So that's two different ways we can do it. We can put it in the same line, which is a little cleaner way to do it sometimes, or we can do it in two lines. Doesn't make any difference to the software. It does it either way. So now we have, I need to end that with another quote string. All right. So now we have some information about you. So we can do a couple of things. So we could say print. If your mother was calling you for supper, she would say, and then we can put in name, dot lower, to imply that, so notice I can just dot lower, and I have to call that function with another set. So that's going to print whatever you type in as a name as a lowercase. I'm going to do another print. If your mother were mad, she would yell name.upper. So we're taking that input and we're flipping it around to a couple of different things using that. So I'm going to try this now. So I'm going to save it first. And what is my name? My name became Bill. How old are you? 12. What is my weight? 45. If your mother was calling you for supper, she would say Bill. If your mother were mad, she would yell Bill. So we did a couple of really kind of interesting things there. Well, now we're going to do a couple of more. So print if you had a baby, they would say. So we know that babies repeat things over and over and over again. So I'm going to explicitly do something kind of interesting here. I'm going to put a line up above here. And I'm going to call that baby equals name times 10. So let's see what happens if we do this. And then I'm going to output baby. So I've manipulated that around a little bit. So I took baby and I hopefully shoved in 10 copies of the name and printed that out. So let's see if that works. Now, if I'm 12 and I have a baby, then we have other issues in this family. So we might want to up our name a little bit. Mark, how old are you? Let's go 22. What is your weight? 22. If your mother were mad, she would yell, Mark. If you had a baby, they would say, Mark, 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 Mark. So that works. We can actually manipulate it that way a little bit. We can also do some other things because we've got your age. So what if we took your age and we said, I want to calculate a value based on that age. So we're going to take that and we're going to say, we're going to call them seconds. And I'm going to take that value of age, which we've already converted to an integer, and now I'm going to figure out how many seconds old you are, roughly. Roughly. So we know there's 365 days in a year, and there's 365 times 24 hours in a day, times 60 minutes, times 60 seconds. And then we're going to print, you are at least seconds. And I don't have to stop with just one. Old. So notice I can put those quote strings in and I can print this. So I'm going to run this one again and try it. And I usually like to try things. So this time I became Mary. Mary's 33. And Mary weighs 101. So if your mother were calling you for supper, she'd say Mary. Here we manipulated it to uppercase. Mary, 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 Mary. And you are at least, and I forgot to put in the word seconds in there. So now I can go back in and change that. All right, so that seems to work. I can manipulate that a little bit. So I need to add the word seconds in here. So I took what we got and I converted it to the appropriate type of content, and I can manipulate it around. So the book talks about then converting your weight into sun weight and moon weight. And so we'll look at that and look at some of those numbers, because we know that that with the gravity is much stronger on the sun. Really hard to stand there. That 10,000 degrees Celsius temperature tends to kind of mess up your hairdo. But we can do that. So we can create something, and I'm going to call this moon weight. And I'm going to take your weight equals weight times, I think the moon is what do they have for a variable in there? They have 1/6. So I'm just going to multiply it times, well, we'll divide it by 6. It'll be fine. Do it that way. But I really want it as integers, so I'm going to define with 2 of them. So I don't want a long decimal string of values in there. And we had assigned it an integer up there, so that makes sense to do. So we're also going to do one called sun weight equals weight. And the sun, I think it says, is like 27 times, so we're going to say 27. So now we have 2 variables that we've created. Now we can do those all in a print statement. The first thing I'm going to do to kind of get some of that mess out of there is I'm going to move down a line. You would weigh, let's do the moon weight. Moon weight, comma, pounds. So now we took that and we created a statement that said you would weigh X number of pounds on the moon. Well, here's what I'm going to do. I want to also do that for the sun, but I'm going to cheat a little bit. Rather than recreate that entire line, I'm going to reprint it, and I'm going to change this to sun weight. And I'm going to change that word there for sun. Remember, programmers, we're lazy. We want to do things as easily as possible. And so now we have you would weigh X number of pounds on the moon, X number of pounds on the sun. So I'm going to run this again. And notice as I've done it in steps, I know that everything up to this point runs. So let's make sure that this section runs. I need another Brenda. My name's now Brenda. And Brenda is 41. And Brenda weighs 175 pounds. So let's see. She would yell, Brenda. And she would say, Brenda, 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 Brenda. You're at least this many seconds old. And you would weigh 29 pounds on the moon or 4,700 pounds on the sun. And be a little melty. So all of those things work. We manipulated that. And that worked really well. Great. I can take a similar type of structure and I can write out something for our assignment. So I do not have Blackboard open right this second. Our assignment, I believe, if somebody has that open. So I'm going to do File New. Our assignment is to create a program at a car dealership. Is that correct still? Okay. Shrink this so it'll fit. Close that one out. All right. So I'm going to put a couple comments up at the beginning so I know what I'm doing. Mostly I'm going to make sure my name is in there. I'm going to make sure that it's week 8 assignment. So those kinds of things are in there. And I'm going to put a little quick synopsis. Calculates prices of car and accessories. So I have that, and I really am going to think about what kind of things, and I'm just going to put this up right here. So it says it wants to input the base price and the accessories and add those all up together and output it, right? So I'm going to put up here, I'm going to kind of do a little brainstorming about what other things. So we know we need the make, we need the model. What else do we need information about? So we need a base price. What other things do we need to know in there? Don't we need a tax rate? Okay. So I know I need to find a tax rate. Is there anything else we need to actually deliberately put in there to start with? We probably want to get the customer's name, right? Okay. Anything else we want to get? So I think that's probably close, and we can get a start on. So the first thing I'm going to do is I want to get the user's name. So I'm going to say name equals, and I'm going to do my input, and I'm going to say welcome. Please enter your name. Now above this, you're probably going to have some text describing the car sales place and other things. So remember, you're gonna take a little time to embellish this and make it a little prettier, but I want to get some of the bones of this in the next 6 minutes. So we're also going to input the make, and so we're going to do another input. You are buying. So I'll probably want to put a new line character in one of these so it kind of moves it down also. So at the beginning. And so now I've got a couple of the pieces of information I need. The next one I'm going to need is base, and depending on if I want to use the underscore or the camel casing, I need to get that base price equals input all right. So that base price, that is a number we're going to use. So we probably need to get a value out of that that makes some sense. Since we're going to multiply it times a percentage, I'm going to suggest for now we probably will want to use a floating number for that rather than an integer. To do that, it's the same way we did before. So I'm going to say base price equals the float of base price. Now, I could do the exact same thing all in one line. I could put that float up there, but this also works. So we've now converted base price to a floating decimal so we can multiply it. Because the other thing we're going to have to set up here is a sales tax rate. We don't need to ask the customer for that. So we know what a sales tax, and so we can use it again. What is a sales tax rate around here? 5%? Okay, or 7, whatever we use, it doesn't really matter. But what does that really mean in terms of a decimal? What is 5% as a decimal? 0.05 or whatever it happens to be. So now we've got this information from our user. Can we calculate what the final cost of that car is going to be? Well, maybe. It also says add in the normal kinds of options. And so maybe we need to come up with some options and what they're going to be. If you've been car shopping, do they let you out the door without a lot of other extras? No. So we could say warranty equals, what's the price on a warranty? $2,000? And maybe they say you need VIN etching. And they want to charge $1,000 for that. What about delivery charges? Delivery, maybe another $500. If you go to that dealership, they're going to want to sell you all kinds of things. So we got the extended warranty. We got the VIN etching. We got delivery. What about dealer prep? So that might be another $500 for them to, wash the car and deliver it to you. What about a maintenance plan that changes all your oil for the next first years? So we have all these other fees we could add in there, right? Okay. So now we have a pretty good set of stuff. So we have a sales tax rate, we get the input, the make, the model, the number, so the price. Now we need to calculate that total. So before we can do anything else, we need to add up what the cost of the car is and figure out what sales tax is, right? So I need one, and I'm just going to call it subtotal. And I'm going to say that's equal to that base price plus, what other things do we have in there? The warranty, which I spelled wrong, I notice. Let me fix that in both places. Are there other things we need to add in? Yeah, our VIN, etching, plus delivery, plus prep, plus maintenance. All right. Did I get all of them? All right. So I'm going to do this really quickly because I want to test it. I'm going to print subtotal. So I'm going to save this program, and I'm going to call this one my car sales. And I want to test this before we do anything else. Before we go any further, I want to make sure it works. So enter your name, and I notice, oh man, I need to put a space in there. And I'm going to be Mark again. Mark likes to buy cars. And he's going to buy a Ford. And he's going to buy a Focus. Oh, could not convert string to float Focus. Well, notice, why did it not do that? Enter the price. So I really probably want to enter make and model. So let's try this one again and just see if I follow the instructions this time, if it actually works. So I may need to instruct my user a little better. So I'm Mark again. The make of the car, let's call that Focus. And the price, all right, it's $10,000. And so I notice up here, oh, yep, I need to put a space in here, put a space in there, but I'm testing for functionality first. So I'm going to run this, and it says, with your additions, that's $14,500. All right, so we know the program works to this point. I know I've got some notes of things I need to do. And so I come over here, and I'm going to say, oh, yep, I know I need a space there, and I need a space there, and I probably need to input the make, the model, and some more information. But I know that my subtotal works. So I'm going to take that print statement, and I'm not going to take it out. I'm going to put a comment tag on it so it won't actually function, but I can use it if I need to, okay? Now I need to figure out what my sales tax is. How do I calculate sales tax? So I'm going to come up with another value called tax. How do I calculate that sales tax amount? When you go check out at the store, I'm going to use that subtotal, so it's all the pieces I added, times, and notice up here I have sales tax rate, and now I've got a value called sales tax rate times that, so I could print that out also to check, but I'm going to do one more. I'm going to call one total, and I'm going to equal that to subtotal plus tax, and I'm going to actually take this and I'm going to change it just to see if it'll print my total. So I have the underpinnings. I don't have it pretty. I don't have it making it very functional yet, but I'm going to see if that's going to work. So Mark We're going to do the same thing. Focus, price. Oh, total is not defined. So in line 20, we end up with a problem. And so that's in our line here. So let's see what happens if I change that a little bit and I say total equals 0 up top. Kind of that. Let's see then if that actually will function. Subtotal plus tax. So we may have to do a little manipulating to see if we can make it work. Enter the price, 10,000. I'll move that up. The term total is not defined. But notice it said capital letters. Maybe there's something else going wrong up there. What else is wrong? So notice I said you got to be careful on your variables. I said I want to assemble something called total with a lowercase t. Here I've tried to print it with a capital T. Let's fix that really quickly and see what happens. And I'm going to enter a focus or something. And so now it actually worked. You have to be really, really super careful about your variable names that you're always using the same one. So now I've got the bones of this. I need to go in and flesh that out and make it usable. So I may add, instead of just printing out that